trip, a payload van leads the move, providing communication with the spacecraft, followed by the ground van providing support to the rocket. The mobile launch platform supplies air conditioning, electrical, and propellant lines to the rocket. Trackmobiles at the rear power the convoy, which includes an environmental control system providing air conditioning to the payload and rocket, as well as a backup generator. Atlas arrives at the pad for fueling and other final preparations, and once fueled, weighs nearly 1.3 million pounds and stands 205 feet tall.
Here on Florida's Space Coast, the weather is often hot and humid as it is today. To withstand the corrosion that could come with these conditions, the Atlas booster is finished with an anodized coating. This coating gives the rocket's first stage its distinctive copper color, while also protecting it from corrosion. Another tool used to mitigate the impact of weather is the environmental control system, which provides air conditioning to the spacecraft. Following a test flight, today's mission is the second ULA launch to deliver Amazon's Project Kuiper satellites to orbit. Let's learn more about Project Kuiper and what they've been doing to prepare for this mission.
It all starts with a countdown. But a countdown to what exactly? 6 years ago, we took on a journey to build the most advanced and the most modern communication system in the world.
There are almost 3 billion people that don't have high-speed connectivity.
Imagine if they had the ability to be connected just like you and I do, what they could do, what contributions they could make.
This mission is ambitious for a truly worthy cause. It's going to impact communities that cannot be reached with fiber traditional communications. The solution really has to be from space.
You can think of Project Kuiper as a three-part system: the satellite constellation, the customer terminal, and just as critically, the ground network and software that ultimately deliver connectivity. We have set out to design the most advanced satellite network ever built, and we have created the whole thing in-house at Amazon. You need just about every technology area to contribute to build the satellite: the propulsion system, the solar arrays, the silicon, the phased array antennas, the optical inter-satellite links.
The team has to be innovative, agile, resilient, as we're moving very, very fast. Building, testing, developing in-house has been an extraordinary ingredient.
When we first proposed Project Kuiper internally, one of the first questions was, can you produce an affordable customer terminal? We knew that was going to be the linchpin of our system.
The big breakthrough for us was combining transmit and receive antennas into a single aperture. No one had ever done this in the K-band. That let us pack a ton of performance into a really compact, really low-cost design. We're going to build tens of millions of these antennas, and we are well on our way. The design is done. We're now in the factory manufacturing it.
We talk about the satellites and constellation, but Kuiper is a satellite constellation being operated as a network across hundreds of ground gateway terminals.
Our ground network is spread out all over the world, and each site connects back to AWS. We already have a bunch of these sites installed everywhere from Australia to Germany, and more of them are coming online every month.
There's a big difference between launching 2 satellites and launching 3,000 satellites.
The past couple of years, my team has really been focused on how to achieve scale. Our own dedicated payload processing facility gives us the ability to control our own destiny. We've got the capacity to integrate up to 5 satellites per day and launch 3 simultaneous campaigns. Heavy lift rockets have higher performance, so we can take more satellites to orbit on any given launch. All of our heavy lift launch partners have had a successful first flight, so that's been a pretty exciting thing for us to see because we made those investments years in advance.
All of the pieces have come together to support that first launch, and the next one, and the one after that. It might not all go perfectly, but we have an incredible commitment to this project and an incredible team committed to its mission. All roads lead here, a countdown to launch. And with more than 80 missions planned, we're just getting started.
As we get closer to the opening of our launch window, let's check in on today's weather. The Space Launch Delta 45 forecast for our early morning launch is looking good. The probability of violating launch constraints is less than 5%. Ground winds are 10 to 15 knots out of the east, and the temperature is currently 78 degrees Fahrenheit. The primary concern for launch today is the cumulus cloud rule. ULA's Atlas V rocket has flown national security, science and exploration, and commercial missions for more than 20 years. As a result, we have a lot of history, or as we call it, family data. This vast library of data is helpful when anomalies occur during the launch countdown. We can refer to the family data to see if the condition is something we've seen before and how we've resolved it in the past. If we experience an anomaly, the planned holds, like the hold we're in now, give our launch team time to evaluate the condition, compare it to the family data, and determine the path forward. Following liftoff, viewers watching launch from Florida and points north and east may be able to see the Atlas V in flight. To get a closer look at this visibility map, check out ULA Launch on social media.
C, verify solar radiation acceptable for launch.
Verified.
LC, this is flight control.
Go.
Launch on time verified.
Roger. LC switch is ready. All steps are complete prior to the status check.
L minus 8 minutes.
We remain in the planned 60-minute hold as we continue towards liftoff. In a few moments, ULA launch conductor Dylan Rice will poll the team for the final go to pick up the countdown. The launch conductor coordinates the launch team during a countdown, similar to a symphony conductor coordinating an orchestra. 28 engineers are polled to confirm the rocket is ready to proceed. This is the final status check for all Atlas vehicle systems, ground systems, the payload, and the U.S. Space Force Eastern Range. Let's listen in as Dylan performs the final poll.
L minus 7 minutes.
Status check to proceed with terminal count Atlas systems. Propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems. Propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Pass gas.
Go.
Electrical systems. Airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
CCQ.
Go.
Op support.
Go.
COM.
Go.
Umbilical.
Go.
ECS.
Go.
Redline monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
Go.
Launch director.
You have permission to launch.
Proceeding with the count. ALC verify T0 is set for 10:54:30 Zulu.
Verified.
Polling is complete, and the team is go for launch. From now until liftoff, launch conductor Dylan Rice and the launch team will continue reporting the final steps in today's countdown. This includes verifying propellant levels and pressures in the booster and Centaur fuel tanks, as well as arming the ordnance for ignition, separation, and flight termination. At T-minus 1 minute, the range confirms it is in a green condition for launch, assuring there are no nearby constraints like boats, planes, or weather, and that all tracking systems are operational. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go Kuiper. This is the final status check for the rocket and payload. To dampen the acoustic shock at liftoff, at T-minus 6 seconds, the launch pad's water deluge system activates, followed a few seconds later by booster engine ignition. Then, after seeing Atlas lift off, you'll hear flight commentator Daniel Brunson providing updates as the rocket ascends into space. While we arm the ordnance systems, we are preparing several key components for flight, such as the pyrotechnic initiated valves, energetic separation systems, and ordnance igniters, which ignite the solid rocket boosters. Ordnance is often associated with flight termination, but there are many additional uses for energetics within the vehicle. This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
The countdown clock has resumed and we are go for launch at 6:54:30 a.m. Eastern. After liftoff, ULA's Atlas V rocket will fly northeast from Space Launch Complex 41. Here's a look at today's flight.
Following final confirmation of rocket readiness, the RD-180 engine and 5 GEM 63 solid rocket boosters ignite to produce more than 2 million pounds of thrust, lifting ULA's Atlas V rocket away from the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Atlas then reaches Mach 1, the speed of sound. The addition of 5 solid rocket boosters, or SRBs, precisely augment the liftoff thrust of the Atlas V, giving it the power to deliver the payload to orbit. With their propellant expired approximately 96 seconds into ascent, the SRBs burn out, followed by jettison. Atlas's guidance system then begins steering towards the precise target in space. Amazon's Kuiper satellites are encapsulated inside a 5-meter diameter payload fairing, which provides protection to the spacecraft during ascent. After crossing the Kármán line, entering space, the payload fairing is jettisoned. With the majority of propellant expended fighting against the force of gravity, the RD-180 engine shuts down and the booster stage separates. The rocket then begins second stage flight, weighing less than 7% of what it did at liftoff. ULA's high-performance Centaur, with its RL-10 engine, ignites, powering the upper stage and spacecraft into a circular low Earth orbit. The first burn comes to an end with engine shutdown, followed by Centaur orienting into the proper position to release Amazon's Project Kuiper satellites to build their low Earth orbit satellite broadband network.
$140,
Launch enabled.
$137.
T-minus 90 seconds. The launch vehicle, ground systems, payload, and eastern range are go for launch. For those of you just tuning in, I'm Ben Chilton, joining you for today's live coverage of ULA's Atlas V launch of Amazon's Project Kuiper satellites. At this time, the team is not working any issues, and we're proceeding towards liftoff at 6:54:30 a.m. Eastern.
Centaur's locked. 1 minute.
Rock, report range status.
Range green. 40.
Stable at step 3.
28.
Verify ECS reduced for launch.
Verified.
20.
Status check.
Go Atlas.
Go Centaur. Go Kuiper.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket, carrying satellites for Amazon's Project Kuiper Internet constellation, continuing a new chapter in low Earth orbit satellite connectivity.
We've ended our pitch over maneuver. Body rates returning to 0. .5 miles in altitude, traveling 1,200 miles per hour. Mach 1, Atlas is now supersonic.
You are hearing Daniel Brunson providing launch
Throttling
vehicle
back up
ascent
to near full power. 2 miles downrange, 6 miles in altitude. Hydraulics continue to look good. Body rates as expected. Atlas continues right down the center of the range track, 6 miles downrange. Entering our next throttle bucket, preparation for SRB burnout. At this point in flight, Atlas is now half of its original liftoff weight, and engines continue to look good. And max Q, maximum dynamic pressure. And good indication of SRB burnout. Engine response continues to look good. Preparing for SRB jettison. Vehicle throttling back up to full power. And we got good indication of separation of all 5 SRBs. Hydraulics continue to look good. Body rates looking as expected. Vehicle's now approaching 40 miles downrange, 37 miles in altitude.
We just heard confirmation of solid rocket booster jettison. These additional motors augmented the thrust at liftoff, giving the Atlas rocket an extra boost to reach its circular low Earth orbit destination. We're coming up on our next mission event, jettison of the payload fairing. Let's listen in.
And 2 minutes to expected VCO. Engine continues to look healthy. Vehicle is now 72 miles downrange, traveling at 5,500 miles per hour. Entering our next throttle segment, maintaining a constant 2.5 Gs in preparation for PLF jettison. And we've got activation of the RCS system on the upper stage. Vehicle's past the Kármán line. We've exited the Earth's atmosphere. Approaching 7,000 miles an hour, 120 miles downrange. And we got payload fairing jettison, and good indication of CFLR deck jettison. Engine continues to burn nominally. "60 seconds to nominal VCO. Hydraulics continue to look good.
Flight commentator Daniel Brunson just called out confirmation of payload fairing jettison. The composite fairing protects the spacecraft as it pushes through the harshest parts of Earth's atmosphere. Next, we'll hear callouts for cutoff of the Atlas first stage engine and separation of the booster stage, followed by ignition of ULA's Centaur second stage engine. These events occur when the first stage has escaped Earth's atmosphere, getting above the Kármán line and into space. The Centaur upper stage, with the Kuiper satellites attached, then takes over on a trajectory to a precise location in space. Let's listen in as we approach these milestones.
And completion of boost phase chill down Engine housing temps responding as expected. And B-coat booster engine cutoff. Good indication of Centaur separation. Got pre-start on H2 and O2. And ignition of Centaur upstage. This will be a 13-minute, 36-second first burn. We've enabled steering on the upper stage. Centaur PU set to open loop.
This is Atlas Mission Control at T+5 minutes. We just heard flight commentator Daniel Brunson confirm the successful completion of the early milestones in today's flight, and all systems continue to operate nominally. The launch team is happy to have another beautiful sunrise launch of the Atlas V here on Florida's Space Coast. As we wrap up today's live coverage, I'd like to say thank you for tuning in to today's flight. I'd also like to remind everyone that for more information about ULA and the Atlas rocket, please visit ulalaunch.com and subscribe to our ULA Launch YouTube channel. And plan to join us for our next launch when ULA's new Vulcan rocket will launch its first mission for the U.S. Space Force. Before we sign off, let's take another look at today's liftoff. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket, carrying satellites for Amazon's Project Kuiper Internet constellation, continuing a new chapter in low Earth orbit satellite connectivity.
We've ended our pitch over maneuver. Body rates returning to 0. .5 miles in altitude, traveling 1,200 miles per hour.